Alright, good afternoon. So, MSM 131, we're going to look at tutorial sheet 3, and we're going to go to question 25. Okay? Alright, so 25 says Tx is equals to A plus Bx plus 2x squared. T of negative 3 is equals to 0, and T4 is equals to 21. Find the values of A and B. Find the values of A and B. Alright, so for us to find the values of A and B, we know that if you replace negative 3, T of negative 3 simply means A plus B negative 3. This is T of negative 3 plus 2 negative 3 squared. But we've been told this is 0, so we have minus 3b. This is 9 times 2, 18. Alright. Then we have T of 4. T of 4 is given as A plus B 4 plus 2, 4 is actually equal to 21. So we have 21 is equals to A plus 4B squared 16 plus 32. Right, so this is the two equations that you will basically have are A minus 3B plus 18 is equals to 0. And the other one is A plus 4B plus 32 is equals to 21. Okay. Right, so by elimination method, I can say subtraction, this is 0. Negative 3B minus 4B is negative 7B. Right, so negative 7B is equals to 18 minus 32. So it's the same as saying minus 18. This is 4. So that's 14. So we have this is, so basically speaking, you say this. This is negative 7b. This is 14, which is negative 14. It's equals to negative 21. Alright? Negative 7b is equals to negative 21 plus 14. We have negative 7b is equals to negative 7 over negative 7. Now for b is actually equals to negative 1. Positive 1. Okay, so basically that's the value of b. Now that we know what B is, we can easily find A. Alright, so we have negative 7B minus 14 is equals to negative 21 there. So subtracting this was negative, so this was negative 14 is equals to negative 21. This became positive, so negative 7 over negative negative, so it becomes positive 1. Therefore, we can find A. From equation 1, we have, even from equation 2, whichever that we want to use. A is actually equals to A minus 3B plus 18 is equals to 0. A minus 3 plus 18 is equals to 0. We have this is 15. So A is simply negative 15. Okay. A is negative 15. So even if we replaced negative 15, negative 15, B1, okay, negative 15 and B1, you notice that these two are going to cancel and it is going to give you 0. Alright, so that's how we find the answer to that. Right, next question. The next question says, now that we found the values of A and B, factorize Tx completely. So we now have, remember Tx was given as A plus Bx plus 2x squared Now that we know what A is, we know that A was found as negative 15 and B was found as 1. So we have Tx is now equals to negative 15 plus x plus 2x squared. Alright, if we write it, it's 2x squared plus x minus 15 as Tx. So now since we are factorizing, the product is negative 30 and the sum is positive 1. So product is negative 30, sum is positive 1. Factors should be 6 and 5. So, but since the product is negative but the sum is positive, we simply are going to have the answer being a positive and the negative. So one of the factors, we have negative 5 and positive 6, because negative 5 plus 6 is actually equals to positive 1. So 2x squared minus 5x plus 6x minus 15. This is going to be x, 2x minus 5 plus 3, 2x minus 5, you have x plus 3, 2x minus 5. Okay, you have x plus 3, 2x minus 5. That's us factorizing. The next question is saying, solve the equation of fx is equals to 0. So Tx okay, so it says hence sketch the graph of t. Hence sketch the graph of t. Okay, so whenever you are dealing with a sketch, one of the things that you need from a sketch, number one, is you need the intercepts, okay? So for starters, we say what is the turning point, okay? So I can use completing the square method with this so that we can get out, we can have the values, the turning point and the like. But we also know that the turning point by formula is given as negative b over 2a, comma, 4ac over minus b squared over 4a. Alright, so you can use this formula. We have a, so you can use that formula or you can complete the square method. So I use completing the square method. So what I'll do is I'll just erase this part. So we know that tx has been given as 2x squared plus x minus 15. Okay. By completing the square method, we have 2 x squared plus x over 2 minus 15. This is 2x plus x over 4 squared minus 1 over 4 squared minus 15. Okay. From this we have 2 x plus, this is 1 over 4 squared minus 1 over 16 minus 15. From there we have 2x plus 1 over 4 squared. 2 multiplied by that is negative 1 over 8. Then we have minus 15. Okay. From here, we can now solve. Okay, so if I change this is going to be 2x plus 1 over 4 squared minus 121 over 8. Okay. From there, we can see that the turning point is given as P comma Q. If we write this in standard form, that is in the form A, x plus P squared minus, or let's say plus Q, right? So the turning point is given as P comma Q. Therefore, here the turning point is actually negative 1 over 4, comma, negative 121 over 8. So this is my turning point. Other than having that as my turning point, the other thing that we now need is the Y-intercept. So Y-intercept, x is 0, right? So t of 0 is actually negative 15 from here. The other thing that we need to sketch is we need the x-intercepts. Okay, we need the x-intercepts, but we know that for us to find the x-intercept, what is it that we can do? For us to find the x-intercepts, we know that y is equals to 0. So it's the same as saying tx is being equated to 0. But if you remember, we already factorized tx, and we had x plus 2. When we factorized, because we were asked to factorize tx at some point. So you can either use the form that we factorized, or an alternative method, instead of factorizing it, is you can actually solve for the one that we've completed the square of. Okay, so that's another alternative. That's another alternative that you can use. But in our case, I think we'll just refer back to what we already did. Right, so we'll refer back to what we already did. So we had x plus 3. Tx is equal to x plus 3 and 2x minus 5. Okay, so from this, we are going to say this is equals to 0, right? So if we equate this to 0, we have x is equals to negative 3 and x is equals to 5 over 2 positive, right? So we have x is negative 3 and we have x as 5 over 2. So those are our two intercepts which we are going to have, and they are the ones that we are going to use, right? Now, we can sketch. Alright, so another thing that we don't know is, if you refer back to what we have, we know that a, from the actual one which you have the actual function, a is actually positive 2. And we know if 2 is greater than 0, then the turning point is actually a minimum. Okay? So this is the minimum turning point which we have. So usually what we do is, whenever we are dealing with these things in the university, we sketch. Alright, so it's not accurate, but what I'll do is I'm going to use all the information that has been given to me. So what information has been given? Part of the information which we've been given is that we know the intercepts, negative 3, okay, and 5 over 2. Alright. We also know our turning point is negative 1 over 4 comma negative, so let's write it maybe here, negative 1 over 4. We know that, let me put negative 3 here. Then negative 1 over 4 will be somewhere here. We have negative 121. Okay, so now the question is, we know that the y-intercept is negative 15, all right? And we know that 15 times 8 is 120, so meaning that this negative 15 here is lower than our turning point. Okay, so the negative 15 is lower than our turning point. So what we are going to do is, we are going to put negative 15 here. Alright, then we are going to have, let's do this. 5 over 2. Okay, so this graph will come like that. It's a minimum, crosses. Alright, so now let's make it look a little bit better than this. Remember, it's not an accurate sketch, but yeah, I want us to show that the turning point and the y-intercept are actually two different points, okay? And that's what you're also supposed to show. Remember, though we're sketching, you have to be a bit accurate in some way, right? 0. This is the x-axis. So we're saying the turning point is negative 1 over 4. So meaning this is negative 15, and you have this as negative 121 over 8. Alright? Then this is a function tx. This is the x-intercept, this is the x-intercept. Right. So that's typically our sketch. That's our sketch. So what's the information that we used? We needed to find the turning point, but we didn't know whether it was a maximum or a minimum. So we checked the value of a. If you check your expansion after completing the square method, a is actually positive 2. Or if you look at the actual function, which was tx, you also still see that your a is 2. Since 2 is greater than 0, we know that the turning point is going to be a minimum turning point. Alright, then other than having a minimum turning point, what we also needed was the x-intercepts and the y-intercepts. Alright, so remember also that this P is also called the line of symmetry. So if we ask you for the line of symmetry, in this case you are not asked, x is equal to negative 1 over 4. Okay, so that's your line of symmetry. So this line here is a line of symmetry. So when you complete the square of a particular quadratic equation, you notice that from here you can actually derive the turning point. This negative p you are seeing here, okay, this is the line of symmetry. It's also the x coordinate at the maximum or the minimum, depending on what we're dealing with, whether we're talking about maximum or minimum. Then also you will notice that the turning point is given as p comma q if you write it in standard form after completing the square. Then I easily derived. If you decide to use this formula, you still get the same turning point, but we advise you complete the square because most of the information can be derived from there. Okay, so what is the minimum value? This q here is our minimum value. Okay, so if you are asked for the minimum value, refer to the q. So in this case, the minimum value is negative 121/8. Okay, so that's the minimum value which you have in this scenario. Okay, what else do we look at? We also noticed that we needed the x-intercepts. X-intercepts, if we were not asked to factorize the first time, all right, what you should have done is after you complete the square, whatever you've done at the end there, just equate it to 0. Remember, x-intercepts means that the point where the graph cuts the x-axis, and we know that along the x-axis y is 0. So this is why we equated the function to 0, okay, or the polynomial to 0. So this is how we get by this. Then you also notice that we have the turning point as negative 121/8, but we also had the y-intercept as negative 15. So how do you basically differentiate the two? Okay, so how do you know which one comes first if you're dealing with a fraction? Just approximate. Okay, so we have 121/8. We know that 120/8 is 15. So therefore, negative 121/8 is lower than negative 15 if you are following the y-axis. Okay, so along the y-axis, negative 15 comes first, and after that, negative 121/8. Now we also say that the graph is not an accurate sketch. Okay, so you have to show all the information. The y-intercept should be shown, the x-intercept should be shown, the turning point should show. Sometimes we'll ask you for the line of symmetry. All right, so that ends that question. All right, so let's go to the next question. The next question. Right, so we're just from doing 25, let's go to 26. 26 is factorize f of x completely, solve the equation of f of x, and hence sketch the graph. Alright, so we have that question. So we have the polynomial to x cubed plus 9x squared minus 6x minus 5. Okay, so this is f of x. Right, so this f of x which we have, we've been asked to factorize it. Number 2, we've been asked to solve the function, and number 3, we've been asked to sketch the function, right? So that's question 26. We've also been asked to sketch the function. So first thing first, we need to know what is the factor involved, all right? So we do not know any of the factors that we have for that. So what do? We use try and error, okay? But usually, we use try and error in order for us to find the factors of this, right? Most of the times, you consider the x cubed, okay? So the coefficient of the x cubed in this case is 2. So let's call this p, okay? So the coefficients of the factors of the coefficient of x cubed are the first that we're going to consider. So in this case, we have positive 1, the factors of 2, positive 1, negative 1, positive 2, negative 2. So it's plus or minus 1, plus or minus 2. Alright? Then we also consider the factors of Q. Okay, so Q is the constant C, the part without an X. So we need the factors of negative 5. Okay, so the factors of negative 5 are negative 1, right? We have negative 1, positive 1, negative 5, and positive 5. So plus or minus 1, plus or minus 5. So if we say Q over P, alright, so if you say Q over P, we have plus or minus 1 as the first, plus or minus 2 as the second. So I'm simply dividing these factors over these factors, okay? So this into that. Alright, so the factors here over the factors there. So we're saying the factors in question, the ones we're looking for, will be somewhere there. Right, so they will be somewhere there. Plus or minus 1, plus or minus 2. If you divide plus or minus 5 over that, so we have so plus or minus 1. Then from here, you have plus or minus 5. Okay. Other than that, if you are dividing over 2, you are going to have plus or minus 1 over 2 and plus or minus 5 over 2. Alright. So the plus or minus is simply coming in because if I say 1 divided by positive 1 is 1, right? And 1 divided by negative 1 is also negative 1. So I'm representing both the negative and the positive answer. Okay, so Q are the factors of the constant and P are the factors of the coefficient of x cubed. Okay, so if we divide those two, this is what we have. So I'm saying the answers to this cubic function here, the zeros of this cubic function, or we can say the factors of this cubic function, can actually be found amongst these. Okay, so it can be any of these. So let's maybe try the first one. If we put, let's say positive 1, what is f of positive 1? So I'm just speaking positive 1, right? So f of positive 1 can be found as 2, 1 cubed plus 9, 1 squared minus 6 minus 5. Okay, so this is 2 plus 9 minus 11. So this is actually 0. Alright, so you see that you've picked one of the factors from there. So the factor that we're dealing with is 1. Now remember that whenever you are trying to factorize, you just need 1, then you can derive the others from the ones that you have already found. Okay. So we're going to use positive 1. Now, what you notice is that I actually replaced x is equals to 1, right? So meaning, what is the actual factor? If I replace x is equals to 1, notice I put 1 here. So meaning that the actual factor is x minus 1. So this one here is a factor. I replaced x is equals to 1 in the original function. Alright, so what is the factor in question? The factor in question, the one goes the other side, so it's x minus 1. So if we notice that the other factor, let's say maybe is negative 5, so meaning if I replace x is equals to negative 5, what is the factor? So if I replace x is equals to negative 5 and I have a 0, then the factor is actually x plus what? X plus 5. Okay, so this is how it works. The number you place, you take it the other side so that you know the actual factor in question, right? So I'm going to use x plus 1, so which is x minus 1 as a factor. So we're going to use the synthetic by synthetic division, or maybe by synthetic. So we had x is equals to 1, so I'll put 1 here, and then we have the coefficients of the cubic function there. So the polynomial has coefficients 2, 9, negative 6, and negative 5. Alright, so now this is how the synthetic division works. The way I'm doing it is exactly how it just works. Alright, So what you do first is you are going to write the coefficients. Remember the value of the factor. So the value of the factor, we said the factor is x minus 1, so you equate that to 0 is 1. So I'm putting positive 1, okay? Then the positive 1 which I have, we're saying the first thing first is we're going to write the coefficients of the polynomial, the cubic polynomials. We have 2, 9, negative 6, and negative 5, alright? So next I'm going to start by first bringing back the first coefficient. So the first coefficient is 2, so I'll rewrite the 2. Always rewrite the first coefficient like that, alright? Always bring it as the first. So then you're going to say 1 times 2, which is 2, so I'm going to write the 2 under the second coefficient. Always rewrite the product under the second coefficient. Then after that, we're going to add. So 9 plus 2 is 11. I'll repeat that. We're saying bring down the 2, okay? So this is the 2 I brought down. Then when I multiply 1 times 2, the number we write it under the second coefficient. Then after this, we're going to add 9 plus 2 is 11. Then 1 times 11 is actually 11, okay? So 1 times 11 is 11, so I'll write it on the coefficient that is following the previous one, alright? So from there, negative 6 plus 11 is actually positive 5. Then 1 times 5 is 5, negative 5 plus 5 is 0, okay? Now, these numbers you are seeing in here, which is the answers you are seeing in there, those are actually the coefficients of the quadratic equation in question, alright? So a cubic function, when divided by the first factor, has a tendency of producing a quadratic equation. So these are the coefficients of the quadratic equation, where 0 is actually the remainder, okay? So 0 is the remainder. Alright, so 0 is the remainder. Then we have one, we're going to write the quadratic equation that we produce from this row. We have 2x squared plus 11x plus 5, alright? So this is called qx, alright? So that is the qx which we have. Now, apart from that, what else do we not? What else do we not? We are supposed to factorize that particular quadratic equation in question. Alright, so next I have to factorize it. For me to factorize, we simply look for the product, the product sum, the product, the sum, and the factors in question. Alright? So what are the products, the sum, and the factors in question? The product is 10. Yes, the product is 10, and the sum is 11. So product is 10 and sum is 11. So now the question is, what are the two factors in question? So what are the two factors in question? The two factors in question are 10 and 1. Okay, so 10 and 1. 10 and 1. Alright, so what we're going to have is, we're saying product is 10, sum is 11, factors 1 and 10. So factorizing this, we have 2x squared plus x plus 10x plus 5. Then we have 2. If you look at that, what's common here is x. Then we have 2x plus 1 plus 2, 2x plus 1. So you can say 5, 2x plus 1. So we have x plus 5 2x plus 1. Okay? So those are the other factors that we are looking for. X plus 5 and 2x plus 1. Okay, so those are the factors. Now, recall that at the beginning, I had mentioned to say, those factors could be, we found out, we had plus or minus 1, we had plus or minus 5, we had plus or minus 1 over 2, and we had plus or minus 5 over 2, right? So if you look at the factors which we have, if I say qx is equal to 0, right? So if I say qx is equal to 0, we are going to have negative 5 and negative 1 over 2. So those are the factors in question, negative 5 and negative 1 over 2. So these negative 5 is here. The first one was positive 1 and negative 5 over 2, you see? So you can actually find the factors from the ones that we talked about. They are somewhere and somewhere there. Right? They are somewhere and somewhere there. They are somewhere there. So this is true that the qx over p can actually give us the factors. So whenever you need the factors, you can rely on that. So how did we refer back to where I talked about this? Okay, it's going to be very helpful for you, especially when you're dealing with these questions. So we have actually come to realize that the factors that we have, x is actually 1, we have x as negative 5, and we have x being equal to negative 1 over 2. Okay, so we have 1, negative 5, and negative 1 over 2. So those are the factors that we have in question, right? So if I equated that to 0, so if we found the other two by equating qx to 0. So if I equate qx to 0, okay, we are going to have x plus 5, x plus 1, sorry, this is 2x plus 1, is equal to 0, so we have x is equal to negative 5, and 2x is equal to negative 1 over 2. Alright, so this is where the negative 5 and negative 1 over 2 is coming from. So that is what we have. Right, so, but that's not the end of the question, is it? That's not the end of the question. That's not the end of the question. So how do we do it? So to find the marking end of the question, we have to refer back to the question. So the question told us not only to factorize, but we also need to sketch. Okay, so there's factorizing, there's also sketching. Now, for us to sketch, remember what we need is we need to know the turning point and we need to know the intercepts in question, right? So that's one of the things that we know. Okay, we need the intercepts and we also need to find the turning point. But usually, whenever we're dealing with cubic functions, we don't usually find the turning point per se, right? So we don't usually find the turning point. We know that this thing is going to have, it's going to turn somewhere, right? So if we want, we can find the turning point using this quadratic, the equation there, right? So let's show you how you sketch it without actually finding the turning point. Right, so in order for us to sketch this, what we need is we need the y-intercept, here x is what? X is 0. So if you replace 0 in the actual original question, the actual original equation, you will notice that you have the y-intercept. You're going to have the y-intercept. I can just refer back to the original. So we have the y-intercept as -5, okay? So f of 0 is actually equals to -5. Right, x-intercepts. X-intercepts, we said y is 0. So this is the same as saying f of x is equals to what? 0. But if you remember, we decided to factorize, okay? So when you factorize f of x, you have x plus 1 multiplied by the other factor was x plus 5 multiplied by 2x plus 1. Okay, so let's put this as 2x plus 1, then x plus 5. Okay, so this was what we had as f of x. When you factorize, this is what you have. So I've just written the factors, okay? So we have the first factor was x plus 1, the second factor was 2x plus 1, and the third factor was x plus 5. So if I multiply these three, to give me back the cubic function, okay, which is f of x. Now we're saying the x-intercept is y is 0, so meaning f of x is actually equal to 0, okay? So that entails that we're saying f of x is equal to 0, which entails that x plus 1, 2x plus 1, and x plus 5 all are equal to what? 0. Alright, so this is what that entails. That tells us that the x-intercept first is -1, the other one is -half, and the last one is actually -5. Right, so the x values that you find, or the zeros of the cubic function, are actually our very y-intercept. These are the x-intercepts that we have in question, right? So it's a beautiful thing. It's a beautiful thing if you really look at it from the mathematical point of view. Know how these things bundle out and how they just end up looking the way you want them to look. Okay, so enjoy this stuff. All right. So we're saying from here we noted that f of x was this when we factorized it, so we can find the x-intercept by equating the function to 0. But since we already factorized, we know that the intercepts that we have was -1, -half, and -5, and we have our y-intercept as -5. All right. So we can actually sketch this cubic function. So how do we sketch it? Sketching this cubic function, number one, we have to first put the intercepts. Okay, so we need the intercepts. We have, remember, -5. We have, let's put it here, -1/2. Then we have the y-intercept as -5. Okay. So the y-intercept is -5. Let's maybe put it here. Then we also have another intercept here as +1. So those are the three things that I'm going to write down. Those are the three things I'm first going to write down. Alright, so now I want to know the movement of the function in question. I want to know the movement of the function. Question 1. Where is the actual function coming from? Okay, so the first thing that we want to know is where is this function coming from? So for us to know where this function is coming from, we need to know what is happening before -5. For us, we need to know what is happening before -5. So pick a value before -5. Let's write down the actual function. So when we factorize the function, we ended up having f of x is actually equals to x plus 1 2x plus 1 and x plus 5, right? Yeah. So actually this is supposed to be x minus 1. It is x minus 1, not plus 1. Take note of that, 6 minus 1, 6 minus 1. So x minus 1, 2x plus 1, and x plus 5, right? So let's pick a value before negative 5, let's say negative 6, okay? Or we can pick negative 10, even better, a bigger number. So f of negative 10, right? What are we going to have? So f of negative 10, you notice will be negative 11, right? I'm not interested in the answer, I'm interested in the sign, okay? Because this value here is going to give us the value in the y, okay? So we want to know, is the value, is this thing coming in the negative part of y? Is it on the negative part or on the positive? This is what we want to know, right? So I'm not interested in the answer, I'm interested in the sign. So negative 11, so negative 10 minus 1 is negative 11. We have negative 10 times 2 is negative 20, plus 1, negative 19, right? Alright, then we have negative 10 plus 5, which is negative 5. So I'm interested in the sign. Is the sign positive or negative? Negative is positive. Negative times negative is positive times negative, the sign is what? Negative. So whatever this value is will actually end up being a what? A negative, alright? So we don't really need to find the value, but we just have to know, is it a negative value or is it a positive value? So now that I know that it's actually negative, meaning the values that are this side are actually on the negative side. So meaning that this thing is coming from the negative y-axis. Are we on the negative side of the y-axis? So we're coming from this direction here. Right, so we're coming from here. Then after that, we're going to turn somewhere here. Then we're going to cross negative half. Okay. We're going to cross negative half. Then after crossing negative half, we're going to turn somewhere. Now, we don't really know where we're going to turn from. Alright, so now I need a bit of some accuracy there. So now the question is, where we're going to turn from? Are we going to turn at this point before negative 5 or we're going to turn after negative 5? Because we have the Y-intercept as negative 5, but we don't know whether we're turning above it or below it. So this is what I now want to test, okay? So to test that, I'm going to pick a number in between negative half and 1. Let's say we'll pick positive half. Let's find out what's happening at positive half, or what value do we have at positive half, right? So we're going to write it somewhere here. Let's say positive half. So we are saying f of 1 over 2, okay? So f of 1 over 2, we're going to have 1 over 2 minus 1. Then I'm going to 1 over 2 plus 1. Then we have 1 over 2 plus 5. Okay, so this is what we have. Then we're going to have negative 1 over 2 multiplied by, this is actually 1 plus 1, which is what? 2. Okay, multiplied by, this is 10, 11 over 2. Okay, so since we are multiplying this, we are going to have this and that will cancel. So we literally have negative 11 over 2. Okay. Negative 11 over 2. Now, ladies and gentlemen, is negative 11 over 2, remember we're not allowed to use calculators, okay? So we are using approximations. Is negative 11 over 2 greater? If we're going in the negative, okay, is it less than negative 5 or greater? It's actually less than negative 5, okay? So negative 11 over 2 is somewhere where? Negative 11 over 2 is somewhere here, alright? So this is where the negative 11 over 2 is. So that implies that the turning point is actually beyond this line, alright? The turning point is beyond that line. So basically speaking, what we have is, because if we had half here and then the answer ends up being maybe above -5, then we would assume that it's actually the turning point is before the -5. So if we had a number not -11/2, but maybe something lower than this, what does it mean? So meaning you're coming from here, somewhere here, then you probably turn at exactly this point, all right? So we are coming from here, we are turning there, going down, crossing, turning, going back, and passing through 1, all right? So that is what we get. Okay, so just to show that we actually, now, this is not supposed to be a straight line, right? So, yeah. So let's just assume this is where my 1 is. Actually, that's where the 1 is. Okay? So we have +1. So this is the nature of the cubic function that we have in question. So this is the f of x. Alright, that is our f of x, so we can label it as that. Okay, so let me delete every derivative that's right. So this is y, this is x, this is 0. These are the intercepts that we found. Alright, the y-intercept, the turning point is here. Alright, so the turning point is right there. Basically speaking, that's how we sketch. Alright, so just note that the turning point is beyond -5. The turning point is beyond -5. That's how you solve that question. Okay, so what did we actually talk about? We said you can actually know, you have to know where it's coming from. Okay, know where it's coming from by testing the value beyond -5. Oh yeah, beyond -5 into the original function. Here we actually ended up having the sign. So I was interested in the sign. The sign is negative, meaning I'm coming from there. But you can also find the value, right? You're expected to find the value of the number that you replace. Usually we don't show, okay? You can replace the value that you are being asked for. Right, so this can be -1045, alright? So we have that. So we had -1045 at f of -10, so meaning at -10 was somewhere here, down here. Remember it's -10, comma. So -10, comma, so we have a value down below there. Right, so this is where the function is coming from. Turns has the x-axis at 3 points, which are the zeros of your cubic function, or we have the points of the factors, right? So this is what we have. End of this question. Okay, let's look at another question. Question 27. Without solving the equation, show that x to the power 4 x to the power 4 plus 4x minus 1 is equals to 0 has roots between x is equals to 0 and x is equals to 1. Alright? So how do we show? Here's how we're going to show. So we are being told that we need to show that that thing has got roots between x is equal to 0 and x is equal to 1. So if I am going to put x is equal to 0 by here and x is equal to 1 here. Alright, so let's just pick 2 points on this. Alright, so I'm going to mark 2 points. When x is 0, what is y? So we're saying for x being equals to 0, let's call this p of x, alright? So we'll say let p of x be this function, alright? So meaning for x being equals to 0, what is p of x? This is p of 0, alright? So p of 0 is going to be a negative what? Negative 1, huh? Yeah, so we are going to have negative 1. So 0 comma negative 1 is somewhere here, negative 1, right? So this is p of 0. Then we have another point. Let's say for x being equals to let's write it here for x being equals to positive 1. Remember, in between 0 and 1. So for x being equals to 1, we have p of 1 is equals to 1 plus 4 minus 1. Alright, which is simply what? 4. So we have 1 plus 4 minus 1, which is 4. So we're saying p of 1 is actually what? 4. So this is positive 4. Right, so if I'm going to so this is p of 1, alright? If we can write this as coordinates, I will say this is 1 comma 4, and this point I can write it as 0 comma negative 1, right? So I'm going to draw a line crossing this. I think I can make my line look better than this. Just say there. So let's say this is 1. Okay, so note that I'll say this is actually negative 1. Okay, so what I just want to do is my duty is to plot the 2 points. Huh? So I'm plotting the 2 points so that the 2 points are combined. Okay, so I'll just put negative 1 here so that it just looks like a straight line. Okay, 1 comma 4 is there, and we have negative 1 comma 0 comma negative 1 there. Okay, so this point here is 1 comma 4, so meaning this is 4, this is y, alright? Now, for lack of accuracy, this is the line that you have. So if you combine these 2 points, p of 1, p of 0 and p of 1, you notice that this actually crosses the x-axis, okay? In between 0 and 1, so hence shown, right? So we're saying, if you join the two points, you notice that the 2 points actually cross beyond 1, 0, and 1. So this is basically how you show. So without solving, it says without solving, show that p of x has got roots between 0 and 1. What are the roots? Remember, we also call the roots as the X-intercepts, are we there? If we're dealing with X in question. So we're saying that the roots can also be known as the X-intercepts if we are dealing with X in question. So in this case, the roots are the zeros, and the zeros that you're talking about are the intercepts. Alright, so if you plot P of 1 and for x being equal to 0 and x is equal to 1, you notice that if I combine these 2 points, there's a line that crosses. So meaning that this particular function crosses at 0 and 1. Okay, so this is how you look at that question. This is how you go about that question. That's basically how you go about that question. Okay. That having been said, we have no further questions to do for today. So we end the tutorial here. Have a good day.